Hello friends, today we're going to pick up where we left off. We're going to finish step 1 of our Lisp with the Make a Lisp guide, and we're going to do some more reader and printer stuff. Where we left off last time was down here in the deferrable tests, and I'm not going to read this. I'm just going to use the failing tests as a guide to try to get all of these passing. So yeah, let's just jump right in. This is the work I haven't yet committed, and we'll just pull up Vim here. And what is the failing test we want to do first? You could really just start anywhere here. Let's start right here. If you have an incomplete list like this, step 1, then it should complete it for you like that, but it also should print out either EOF, end of input, or unbalanced. And so we'll just go with EOF, and we'll do that in our reader, read list. And the way I'm going to do that, I think right here, instead of doing a break, I'll do return list. And if we get out of this loop without hitting this return, then let's do C error, I guess, EOF. And let's see if we get some passing tests. So where we left off, we had 87 passing tests, and we'll run the test suite again. By the way, this is now the 3rd time I'm recording this video, so if it doesn't seem as spontaneous, that is why. We're up to 89 passing tests. I just had a series of unfortunate events, and I won't get into all the nitty-gritty detail, but suffice it to say, I made some mistakes in recording both of the previous times, so hopefully 3rd time is a charm. Good news is you don't have to see me stumble a lot in this video. We should be able to get it done pretty quick. Deferrable, that is all passing. This, we don't have this yet. So let's do a vector. Now, it tells you in the guide here, but the difference between a list and a vector in Lisp, normal Lisp is quite different. A list is what's the word? A linked list. It's usually a linked list. Each part of it is a con cell, and there's all kinds of history there with Lisp. I'm not going to get into that. In Mal, Joel Martin, who made Mal, made it really simple. List and vector are essentially the same. They're both just vectors, and there's no need to build linked lists and stuff. So the good news about that is we can do a read vector just like we do read list, and I'm literally just going to copy paste. I'm probably not going to win any awards for this code, but I don't care. So I guess we need a vector value. I haven't built this yet, but we will in just a sec. Vec and vec. Wow, I'm really struggling. Vec and vec. And so now we need to build it. First though, let me go just make this real quick. Vector, and then we'll go to type. And I'm just going to subclass list value. It's just going to have all the same functionality, essentially. And we'll need to make this protected so that it can get to this data member. I guess we need to add that as well. And we need a constructor. So vector value, just an empty constructor. Cool. And in type CPP, we're going to copy this vector value, inspect, and we're just going to change the parens and have it use square brackets. So there's that. This should now be happy. that should go away. Why are you not going away? Class vector value, public list value. Did not save that. What have I done wrong? Class. Oh, I know what I did wrong. Public. Didn't have that public. There we go. Read vector. So we need something that calls this. That's real easy. That's right here in our read form where it branches off. We're going to have it read a vector. And so we should get some more passing tests. So 89 passing tests goes up to 97. We got a lot of free passing tests for that. So great. Okay, so let's look at anything else. We're going to need to do hash maps here pretty soon. Those are all success. Yeah, so let's go ahead and work on hash maps. Hash map, we're going to use the unordered map from the standard library as like the underlying data type. We're not going to implement a hash map. We're just going to wrap it. And so we can get started on that. So we'll do class hash map value public value. Public hash map value, just an empty constructor like that. And we do need a virtual inspect function, private, and then the private member for the data will be a stud unordered map. The keys are going to be value pointers. The values are going to be value pointers. And then we need two things here that we'll come up with in a second. I'll come back to that. And we'll call this mmap. And we don't have that yet. So we'll just add it here. Unordered map. What is that? Oh, that's weird. Okay. So I know you're still not happy with me. Probably just because of the underscores. Yeah. What is that? Yeah, it's probably just the underscore, I think. So the way we have to do something. It has to be able to compare. It has to be able to hash the. What's the word? What am I looking for? Hash the keys. And it has to be able to compare two keys to see if they're equal. And so we need to build two things. We need to build a function object for the hash and for the equal to. The way that is done is you scroll down here and you copy paste this code. We're just going to steal this right here. And I'm going to put this here and I'm going to call it hash map hash. And it's going to accept a value star key, I guess. And we don't need this junk, but we're going to return this stud hash of a string, yes. We're going to call inspect on it. And this is kind of a cheat. I don't know if it's a cheat. It's probably not very efficient because if we have a huge list or a huge string or something, well, actually, I don't even know how to make this more efficient. There's probably a way. I'm not going to worry about it. But basically, if we have like a really big nested structure, like lists within lists within lists, I mean, we're going to have to print that to a representation that is visible. How do I say this? A printable representation, and then turn that into a hash. And it's just not going to be super efficient. I guess, the caveat there is don't use a really big thing for a key and a hash map. It's just going to be inefficient no matter what we do. So I think I'm okay with this. So I think you can guess. That's going to go right here. Hash map hash. And then this one is going to be, go away. Another function object that implements this operator callable. It's going to be a lot like this one. Struct hash map predicate, I guess. And we're just going to paste this. It takes a value star left-hand side and a value star right-hand side, and it returns if they are equal. And for now, I'm just going to say if they're literally the same pointer, then they're equal. I know this is wrong. I'm just going to put a fix me here because I don't think we need to mess with that for now. We'll implement equality, like a real equality later. I'm just not ready to do that. So this works for now. If it's the same pointer object, then we'll return true. And so, yeah, so that goes here, HashMap pred. And does that make you happy? No, because I didn't put a colon here. That was the missing thing. So now we have this HashMap value. We need to implement the inspect function on it. Type cpp, and I'm going to copy this and do HashMap value inspect. It's going to look similar, a little bit different. Map, and I think this returns a pair. I'm just going to go with it. I think that's possibly right. So pair dot first and pair dot second, and then another space. And then this is a curly brace. So we have our inspect, so we can print it back out. What else do we need? We need a way to read it in our reader. So we can now build the data type and we can print it, but we can't yet read it. So we'll do this read HashMap, and it's going to be similar to this. So more copy paste HashMap. Yeah, so the first time I recorded this video, I was in the car. I was waiting on my kids to get out of swimming, and I just have this hour a couple times a week where I can sit in the car and hack on stuff. And I've done a couple videos like that where I'm in the car programming, and they've turned out okay, I think. Not the best, but okay. But for whatever reason, this time there was like some ground loop interference or something, and the audio was just horrible. So I threw out that video, and then the second time I recorded it here in my office, and I accidentally, I guess, had slid the mic volume down a bunch, and so that audio was trash as well. So here we are, a third time I've done this. Good news is you don't have to see a bunch of the mistakes. Probably still seeing some mistakes, to be honest, but not as many mistakes. I'd like to think. HashMap value and map and map and map. Okay, so we're not going to be pushing. We're going to do set. We haven't built that yet. Let's go build that. Why are you complaining? Oh, because this is supposed to be HashMap value. I guess we'll do auto key equals read form reader and val, and we'll do key val something like that. Now let's go implement set. We don't have a set yet. We'll do void set value star key value star val and mmap key equals val. I think that's what that will look like. So you're happy. Might as well do the get while we're here. Get the key. I always forget how this works with the map from the standard library. I think use find. Yeah, look, it's already purple. This is what I did last time. Use find, and I'm just going to copy this code right here, and it returns a pair pointer that has a first and a second. So let's do mmap find key mmap. If it's not end, then we're going to return search second. else we're going to return a null putter. And but that's not void. Value star. Yeah, well, we did that. And we got the reader. I think because this is reading two values, I think I need to repeat this. So auto token equals reader.peak. So if this if this token is a brace, I want to print something. I'm not really sure. I don't have any exceptions right now, and I don't want to do that yet. We'll say hash map key without value. And we'll just return the map. So it won't add that key or that value. I feel like that's a good way to do that. Yeah, that feels okay. Let's just test it. Make step 1 read print. Let's just see if it even compiles first. It doesn't. Oh, it's not declared. Okay. Reader HPP. We need a read hash map value. Uh, 39. I did some copy paste. Wait, 39 of what? 39 of types. This was supposed to be map. No, mmap. Okay. So if I have 1, 2, like so, and 3, yep, 4, and you can see it is unordered. Okay, I feel like that is good. Let's run our tests. We have 97 passing tests. We're up to 107. There's only 10 left. Look at that. So everything we have left to get passing is this quoting stuff. And this is stuff for macros that we'll get into later. For now, we just need to teach our reader how to convert. So it needs to convert this to this. And these tests are a little hard to read, but that's essentially what it wants. So anytime there's a little single quote, then we need to turn it into a list with the first item being a quote symbol followed by the value. So I believe we want to go back to the reader and we want to do that here. And we'll make this read quote, read quoted value. Value star read quoted value, reader, and we'll just put this over here. Okay. So let me just check this. We're peeking at the tokens. We haven't consumed it. So I think we need to do something similar here. We're going to say if this is a single quote, default, not sure what to put in there yet, but if it's here, we're going to say std error, bad quote, and abort for now, because I just don't want to accidentally get in here and not know it. I think this is a good habit. I don't know, there's probably a better habit, but I do this a lot. If I'm building a switch statement or an if, and I'm not sure what's going to happen in the else part, then I'll throw an abort in there. At least I'll have a good exception to go with. So if we have a quote, then we definitely want to consume it. So we'll just consume the quote, and then auto list equals new list value. and we're going to push a new symbol value. Is that right? I believe so. And then we're going to read form reader here and return the list. Seems right. Is that right? Well, you know, one way to find out. Let's just run our test suite and see. So we had 107 passing tests and we're up to 109. So I guess we did it right. And so now we're going to do the back tick becomes a quasi quote. And again, this doesn't really, I mean, it's going to be explained later. It's going to be explained later. Just trust me. Quasi quote. I mean, this is a little bit repetitious. I wonder if there's I don't care. There's probably a way to make that less repetitious, but I don't care. We're just going to get it done. Just going to get it done. Did I mention this is the third time I'm doing this video? It's okay. It's okay. Unquote is a tilde. Unquote is a tilde. We're just going to do a tilde, and we're going to do tilde here. I'm going to say unquote. So we go up from 111 to 114. Oh, look, we're so close. This is all we have left. I'll leave that one for a second. Deref is not really a quoted thing, but it looks like it, so I'm just gonna call it good. That is the @ sign. And copy this again. @ sign deref. So 114 should be up to 115, I believe. Yep, and we only have two failing tests now. This one is splice unquote. And it's a tilde followed by an @ sign. It's a little bit different. Tilde followed by an @ sign. We're going to say, I guess if token value dot length is greater than 1, token dot value dot tilde @ sign. Then we're going to do this. Otherwise, we're going to do this. And we'll just paste this in here, and this is going to be splice unquote. So that's right. 116. Oh, okay. Last one with meta. Apparently, I've never actually used this in any Lisp, but something that we have is if you have a caret followed by a hash map followed by a value, then it turns it into this structure. And I'm just going to copy this over so we can really look at it. And I guess we'll paste it here. So I want to just clean this up so we can kind of see exactly what it does. So let's paste this, and we'll look for the caret, and we'll do read with meta, and we'll take this with us. Read quoted value. Put that there, and oops. We'll put this here, and we'll do read with meta, and we'll put this right here. We're trucking right along. So we want to consume that. Not sure what I did there. Consume the caret, and then, well, yeah, we'll just copy this. It's going to be similar to that. We need a new list, and we're going to return the list. And the metadata is this first hash map thing, and we're just going to assume it's a hash map. I probably shouldn't assume. But if it gets the test passing, then I'm going to call it good. Read form reader, and then this is the value, and we're going to read form for that. So it goes in that order, but when we're building this list, we need to do it in the opposite order. So we're going to do list push value, list push meta, return the list, see if our tests pass. No, apparently not. What did I do wrong? Whoa, baby, with expected got. Oh, I forgot to add the with meta symbol. Yeah. We'll just copy this and paste this, and we'll do with meta. So now does it pass? It should. It does. All the tests are passing. It feels good. I mean, we did a lot of work. If you count this video with the last video, let's just glance over it. We're gonna say step 1, add reader and printer. And I don't think I showed it, but in the last video I was struggling with this a little bit. I did remember that, or look up that the syntax is the caret. So if you know what, this probably make more sense if I just look at the make file. So yeah, instead of having to repeat all of these dependencies here for the compilation, then you can just use $caret and it copies them from this line above. So I had mentioned that in the last video, and I've just wanted to follow up. But yeah, so we added a tokenizer and a reader, and we've even added some data types. Oh, I need to get rid of that. I'll do it in a minute. Lists and vectors and hash maps. And oh man, I'm pretty proud of the tokenizer, even though I struggled with it in that last video that you saw. That was a lot of fun. Even with the mistakes, I had a lot of fun. And we've got our main is getting a little bit bigger. There's a little bit of more meat here where we do read stir and PR stir. And yeah, each of our types has an inspect. Actually, do they? Does every type have an inspect? Like, what if I inspect a symbol? Oh yeah, it just returns the string. Yeah, that makes sense. Well, let's commit it and let's be done. And let's make sure all the tests still pass. Oh, I was gonna fix this, right? I was gonna get rid of that. Amend the commit and make sure the tests pass. Yep, and just make sure step 0 tests still pass. Perfect. We're going to push it and be done. So thanks for hanging out for this video. Oh, stay tuned for the next one. The next one's gonna be, I can't wait to do this one. This is gonna be so much fun. Eval. We're gonna actually make our Lisp do something. It's going to do a little bit of math. We're going to add plus and minus and multiply and divide. Thank you very much. We're going to add plus and minus and multiply and divide. And we'll have a little calculator. So we can do plus 2, 3, and get 5. Oh, it's going to be so fun. So definitely stay tuned for the next video. And thanks for hanging out. I'll see you next time.